Hi, today we're going further in depth on our discussion of atomic structure. In our last meeting, we talked about the periodic table and how it's grouped and sorted, and how elements are placed on the table based off of their characteristics. Today, we're going to begin to learn about the things that make up our elements. So, if you had to guess, how many copper atoms do you think are in a penny? Great. So there were some great guesses during that time. Let's talk about how many copper atoms there actually are in a penny. There are approximately 2.4 times 10 to the 22nd atoms. So that is 2.4 and 22 zeros behind that number. The radii or radius of most atoms is 5 times 10 to the negative 11 to 2 times 10 to the negative 10. So they are very, very, very small, infinitesimal, tiny, 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 tiny little structures that make up everything around us. We know that pennies are very small. So to imagine that there are 2.4 times 10 to the 22nd small structures making up this one space seems almost impossible. So that's why we're going to discuss atomic structure. Let's begin by discovering our subatomic particles. You might be familiar with this shape if you've watched Jimmy Neutron. This is what we consider the basic structure of an atom. You have inside of the nucleus protons, seen here as yellow balls, and neutrons, seen here as green balls. And then floating around the nucleus of the atom, you have electrons. So, what are these very tiny, tiny particles that make up an even tinier, or what are these very tiny particles that make up a very tiny substance? Protons are positively charged particles represented by a P or a P plus, and they are located inside the nucleus. Their mass is one atomic mass unit. Neutrons are neutrally charged atoms. That means they have no charge, represented by an N with a small zero next to it, and they are located inside of the nucleus, as are our protons. They are also equal to one atomic mass unit. This is essentially saying one atomic mass unit that something has a mass of 3.661 times 10 to the negative 27th pounds. So again, super tiny. Electrons are negatively charged particles represented by an E minus, and they exist in what we call the electron cloud, which is just to say that they orbit the nucleus. And electrons are even tinier than our protons and our neutrons, coming in at 1 to the 2000th atomic mass unit. So, how do we write this information? How do we know this information just by looking at a small box on the periodic table? Well, we use different types of what we call notation, which is just to say, how do I write this out? If you're looking at your periodic table, or you don't have to because there is an example of this on the screen now, you'll see one of the boxes that exist on the periodic table. At the top, there's a number 10. In the center, an abbreviation. Here, a name. And then down here, a number again. These two items in the center, the Ne and the neon, are the chemical symbol and the chemical name. The other two portions are extremely important because these are how we identify our elements if we don't have access to neon or the Ne. So, how do I know that an element is an element? If I'm a scientist and I'm in the lab, how do I know that the atom that I'm looking at is actually an atom of neon and not, say, carbon or oxygen or fluorine? I know this because elements are different because they contain different numbers of protons. To help us identify different elements, we've simply numbered each element by the number of protons in the nucleus. We call this the atomic number. So the atomic number is simply the number of protons in the nucleus of an atom of that element. So neon will always have 10 protons in its nucleus. Just like oxygen, for example, will always have 8 protons in its nucleus, and carbon will always have 6. Underneath the name, the chemical name of the element, we have what we call the atomic mass. The atomic mass is simply the average mass of all isotopes or variations of neon on the planet. And we'll talk more about that when we begin discussing what isotopes are. There is another way that we can write out the pertinent information or the important information about an element, and that's called nuclear notation. You take the chemical symbol, which again is just the abbreviation, which is sometimes the first two letters of the chemical name, but not always, so don't get attached to this. And we place the atomic number, which for neon is at 10, at the bottom left-hand corner, and we place the mass number at the top, which for neon is 20. So just a quick recap. The number of protons defines the element. The number of electrons and neutrons in an element can change, but for example, carbon will always have 6 protons. If carbon had 7 protons, what would it become? What if carbon had 5 protons? What would it be then? Excellent. So let's spend a little time and practice getting the pertinent information off of the periodic table. Let's start with chlorine. Chlorine's chemical symbol is Cl. Its atomic number is 17. All right. So now that we've spent some time filling in the blanks on this slide, let's talk about mass number. Now, I know that when you were going through that chart and you were filling out the blanks, for the mass number, you were probably just placing that decimal that's underneath the chemical name in that box. However, the mass number is actually not on the periodic table. The mass number is a whole number. Remember that the number that is on the periodic table, typically a decimal, is the atomic mass, aka the average of all masses of isotopes all together. The mass number equals the number of protons, or the atomic number, plus the number of neutrons. Adding these two together tells us the actual mass of an individual atom of an element. In order to know the mass number, it is either given to you or you must have the number of neutrons. You cannot find the mass number on the periodic table. So how do we calculate subatomic particles? Simple. The atomic number is always equal to the number of protons, and in a neutral atom, the number of protons is always equal to the number of electrons. That is to say that carbon has an atomic number of 6, it has 6 protons, and it has 6 electrons. If the mass number equals the number of protons plus the number of neutrons, then how do we calculate the number of neutrons if we only have the mass number and the atomic number? Again, simple. Neutrons is just your mass number minus your atomic number. So if you're in a situation where you're given the mass number of an element and you need to find the number of neutrons, you'll simply subtract the atomic number from the mass number. We're going to put that into practice here.